This is section 3.3, and in this section we're going to talk about types of statements. So we introduced what a statement was a couple of sections ago. We said that a statement was a declarative sentence that was either true or false, but not both. A statement that's always true is called a tautology, whereas a statement that's always false is called a self-contradiction, or sometimes just called a contradiction. So I give you some examples. A tautology, a statement that's always true. 6 plus 3 equals 9, right? Always true. 6 plus 3 equals 4, always false, right? So let's look at some of these statements where sometimes they're true, sometimes they're false. It just kind of depends on the scenario, right? So let's let P be the statement, I will get a haircut. So not P, this negation of P, would be, I will not get a haircut, right? Because of that little negation symbol. If I make a truth table for the and the or, the conjunction and the disjunction of these two statements, it's going to look like this. I've got P, which has two options, true and false. Not P is the opposite. Instead of true, false, it's false, true. If I do the disjunction, or the or, of these two columns, the or says that one or the other of these two options needs to be true. Well, in this case, that one's true, so it makes the or true. In this line, this one's true, so that makes the or true. The and of these two statements, and requires both to be true in order for the and statement to be true. Here, both of them are not true, so it's false. Both of them are not true, so it's false. This entire column is all true. So we say that this statement is a tautology, meaning it's always true. Whereas this column is always false. So we call that a self-contradiction. So our truth tables are going to be bigger than this. We know that we're going to have P and Q, so we're going to have 4 rows to them. So we're going to have a little bit longer columns here, but the same premise holds here, that if it's all true, then that statement at the top is a tautology. If the column is all false, then it's a self-contradiction. If it's a mixture of trues and false, then it's just considered neither a tautology nor a self-contradiction. All right, so we're just going to dive right in, and we're going to determine if a statement is a tautology, remember, all true, a self-contradiction, all false, or neither, a mixture. Here's the statement. Now, I went ahead and built the truth table with these extra columns in here. Remember, Alex is not going to give you those. It will likely just give you these two and then this one. It will most likely not give you these two intermediate steps. You need those intermediate steps. You cannot just go straight from here to this answer. So you do need to put those intermediate steps either in Alex or on your paper before you enter that answer. Okay, so let's bust out this summary of connectives that we talked about in the last section. Here, I'm going to do what's in the parentheses first, that conditional from P to Q. I'm going to do the not Q, and then I'm going to disjunction or those two together. This P to Q, this conditional, is just my standard issue P to Q. So I can just copy it down from this column. So it's just true, false, true, true. So true, false, true, true. And I'm just going to make a note here that I copied it from my summary sheet. Not Q. I'm just going to come back over here to Q. That negation right there. And then I'm going to do it to that column. Okay, so true, false becomes false, true, true. And then last up here is just this or operation, that disjunction, and I'm going to be doing that or operation to that column and that column. So this stuff and this stuff are being ored together or disjunctioned together. My disjunction is an or. It's only false when both are false. Okay, let's keep that in mind. This is only false when both of these are false. All right, are both of these false? No. 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 Remember, this column is only false if both of these are false. That never happened, so it's always true. Because this statement is this column right here, this column is all true, so the statement is a tautology. You don't have to look at the other columns. You just care about the column that goes along with that particular statement. All right, so let's look at this next one. This is a pretty complicated statement. So you can see that it took a lot of columns to build up to it. So let's take a second and look at that and see how I built this truth table. Because again, in ALEKS, you're going to be given these two and probably just this last column, and you're just going to be left to your own devices to figure those out. All right, so in the parentheses, right, so I did that. Then over here, I work inside the parentheses, but wait, the parentheses have two things happening. I've got a not P and I've got a conditional. I'm going to have to separate those and do one at a time. The not is just attached to the P, so I'm going to do the not P first. Then I'll do the conditional from not P to Q. Remember, I'm only doing one operation at a time. Okay. Let's get out our summary of connective sheet. This is just your standard issue disjunction, just your plain old P or Q. So I can just copy that down. True, 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 false. So true, 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 false. Again, copied from that summary sheet. Not P is just the negation of P. So that's instead of true, true, false, false, that's false, false, true, true. This is a conditional statement. It is going from the not P to Q. Remember, these are very direction specific. So we got to make sure we notate that direction. That conditional is a promise. It is only false when you go from true to false. The direction matters. Remember, it's only when there's a fire, but you don't call 911. All right, remember, we're going from not P right here toward Q. So false to true. That one's okay. That means there was not a fire, but you still called 911. Maybe you did it for some other reason. That's okay. You didn't break your promise. False to false. That's okay. No fire, you didn't call. That's a normal day. True to true. There was a fire. You did call. You kept your promise. True to false. That's the bad one. That's the one where there was a fire, but you didn't keep your promise. So there's your false. All right, and then this last column, as messy as that looks, it's really just one operation. It's just that conjunction or that and of two columns. Okay, so it's the P or Q column, so it's this stuff, and then it's this conditional that we just did. So I'm going to do the and for those two blue columns. The and is only true when both are true. Remember, and requires that you do both things in order for the and statement to be true. So it's only true when both are true. All right, both are true, cool. Only true when both are true. Both are true, cool. Both are true, awesome. Uh-oh, both are not true, so it's a false. This felt like it was about to be a tautology, but then this false messed it up. All right. Remember, if it's a mixture of trues and false, it can be any mixture. It can be half and half. It can be just one of them to mess it up. Just if it's not just straight true or straight false, then it's a neither. Remember, if it's all true, it's a tautology. If it's all false, it's a self-contradiction. If it's a mixture, it's neither. And remember, we're only looking at that last column because that goes along with that statement. That's the only statement we're asking about, it being a tautology, a self-contradiction, or neither. All right. So let's look at this one. This one's got some biconditionals. We haven't done a whole bunch of those. So this is a big old mess right here. So let's look at how I had to build my truth table to get to that. So there's the parentheses. So I did that one. These parentheses though, hooey. Okay, I got a biconditional and I got two negations. So I need to do the two negations first. Then I need to biconditional those two negations together. Then I can do this conjunction between those two quantities. Okay, let's get out that summary of connectives. The first thing is that biconditional. That's just your standard issue biconditional, P, biconditional Q. We can just copy this down. True, false, false, true. So true, false, false, true. Make another note. That was just copied from the summary sheet. This is so we don't have to go through and reason them out every single time. You know, some of these basic ones that we do all the time, we don't have to go back through and, redo them every single time. Okay, not P and not Q. Those we know are super easy. They're just the negations. So at this point, I would encourage you to pause the video and see if you could go ahead and fill in some more of the table. See how far ahead of me you can work. Remember, with math, you cannot just learn by watching. You have to actually practice. Remember I said it was like a sport, right? You can't just go to a whole bunch of basketball games and watch a bunch of people play basketball and expect to be great at it. You have to actually practice yourself. It's the same thing here. You have to practice. So pause the video and see if you can fill in these two. And then use that summary sheet to see if you can fill in this one as well. Okay, so not P is just the opposite of the P column. So we've got true, true, false, false. So that'll be false, false, true, true. The not Q is going to be the opposite of the Q column. So instead of true, false, it'll be false, true, false, true. All right, this one. We've got the biconditional. We got this biconditional of these two. We don't use the biconditional a whole lot. The biconditional is only true when both values are the same. Now remember, I'm not just going to copy this down because that's not just a standard biconditional of P to Q. I've got the knots in there. If it were just the standard P to Q like that one, then boom, copy it straight down off of this. But instead, because it's not the just, plain old P to Q, I'm going to have to use this. It's only true when both values are the same. Okay, so are these two the same? Yes. Are these two the same? No. One's false, one's true. Are these the same? No. Are these the same? Yes. The biconditional is only true when both of these values are the same. All right, last up, this mess, but really it's not a whole bunch of stuff. It's just one operation. It's just that and it's the and of that column and this column. So I'm really just narrowing your vision that I'm just going to do this conjunction to those two columns. All right, so going back to this. My conjunction, my and, is only true when both are true. This is only true when both of these are true. Okay, true, true. Okay, only true when both of these are true. Both of these are not true, so that's a false. Both of those are not true. It's a false. Oh, both of those are true. Because this is a mixture of trues and false, it is neither a tautology nor a self-contradiction. A self-contradiction would be straight falses. A tautology would be straight T's. Any mixture is going to be a neither. Okay, next up, two compound statements that have identical truth values are said to be logically equivalent. So it means that in a big old truth table, if I've got two columns that have identical truth values, then those statements are logically equivalent. And we're saying this for compound statements here. Two compound statements that have truth values that are exactly opposite are said to be negations. So let's see how that's going to play out. This is how it's written in ALEKS, okay? It says determine if the two statements are logically equivalent, negations, or neither. Remember, they don't have to be one or the other. Logically equivalent means that their truth value columns are going to be exactly the same. Negations, they're going to be exactly opposite. Well, what happens if some of the values are the same, but some are opposite? Well, that's where we get the neither. This is how it's written in ALEKS. It's got this semicolon that is separating the two statements. Okay, so I need to build a truth table where this is one column, this negation of the quantity P or Q, and then another column is this P conditional, not Q. All right, so I cannot just go straight to, well, I guess I could, but I'm not. I'm going to go straight to that one. I do need this or first, what's in the parentheses first, then I do what's on the outside of the parentheses. So you can see I got the disjunction, then the not of the disjunction. Then for this statement, I need that not Q first before I can do that conditional. So I got the not Q, then I've got the conditional. All right, let's do it. That's just your standard P or Q disjunction. So we can just copy it straight from the sheet. True, 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 false. So true, 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 false. So I copied that from the summary sheet. This is just the negation of that previous column. So it's just the negation of that. Okay, well, instead of true, 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 false, the opposite would be false, 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 true. Easy peasy, right? The negation of Q is just that not of Q. Instead of true, false, that'll be false, true, true. And then last up, we have this conditional statement, this if-then. It's going from P to not Q. Remember, these are directional, so the direction is very important for these. All right, this is the conditional. It is a promise. It is only false when this thing happens and then you don't follow through, when the promise is broken. Only false when it goes from true to false in that direction. All right, so we're going in this direction, left to right. So true to false. Oh, that's the promise broken. True to true, that one's okay. False to false, that one's okay. False to true, that one's okay. The only time it's false is when you go true to false. Okay, now where do we look? These were my two statements, so I need to identify those two columns, okay? This not P or Q column is right here. So there's that one. And then this if P then not Q column is right here. Those are the two columns I'm comparing. Are these two logically equivalent. Now, logically equivalent means these two columns are exactly the same. Okay, obviously they're not exactly the same, right? False, not the same. Are they negations? Now, negations means they're exact opposites. So instead of false, this would have to be a true. Okay, yeah, no. It actually looks like that one's the same, that one's different, that one's different, that one's the same. It's a mixture, so it's a neither. So these two columns are not exactly the same, nor are they all exact opposites, so that must be a neither. So I don't want you to get this confused with the previous examples where we were just looking for that one statement and asking, is it a tautology or a self-contradiction or neither? That one we only needed to look at that one column. This one we're actually comparing two statements. So I'm going to need to compare two columns. I didn't just willy-nilly just pick those two columns. I picked those two columns because those were the two statements that were given in the original problem. Okay. All right, so you might remember from sets back in chapter 2, we did De Morgan's laws for sets, and it says that the complement of an intersection is the same as the union of the complements. And similar for the complement of the union is the intersection of the complements. We have a similar version for logic. So we have that negation, which is similar to the complement for sets. That negation of this and, this conjunction, it kind of looks like I'm distributing that negation. And I mean, you can kind of think of it as that, but I do have to flip that conjunction to a disjunction. Or if it's already a disjunction, I'm going to flip it to a conjunction. So let's see how to use De Morgan's laws to write the negation of a statement. So I will study or I will nap. Okay, so this, if I say that statement P is I will study, and statement Q is I will nap, then this in symbolic terms is the or, the disjunction. This is P or Q. The negation is going to be the negation of that P or Q. Using De Morgan's laws, that is going to be this bottom one here, is that not P and not Q. Okay, so here's my statement. The negation of that statement is going to be this, negation of that or statement. This is using De Morgan's laws. So now let's write this in word form. Okay, not P will be I will not study. That's an and, the conjunction. And not Q is I will not take a nap. So this is my final answer. So if you say that I will study or I will nap, the negation of that is basically not doing either one of those. So I'm not studying and I'm not napping. Right? Same directions as last time. It is raining and I do not have an umbrella. Okay, so let's say that P is it is raining. And Q, you could do this a couple of different ways. I'm going to go ahead and just say Q is I do not have an umbrella. I'm going to go ahead and just include that not in that Q statement. You certainly don't have to. You could say that Q is the statement, I do have an umbrella, and then write this as not Q. I'm just trying to make this a little bit less symbol heavy. All right, this one's an and. So this is a P and Q. All right, so that means the negation is going to be not P and Q. Using De Morgan's laws from the previous page, that is going to be not P or not Q. Okay, so again, that's from De Morgan's laws. So now we have to write this in word form. So not P is it is not raining. That's an or. Ooh, what is not Q? Now, let's think about this one for a second. Q is I do not have an umbrella. So what is the negation of this? How would you write that in word form? What is that negation of I do not? If you already do not have one, what is the negation of a not? What means you do have an umbrella? So that not of that not is like two negatives making a positive. So this is your final answer here. This one was kind of messy because of the original statement having a not in it and having to negate something that was already a not. That can get kind of messy. So I called this compound statement, P and Q. It was an and. The negation is that not of that and statement. Using De Morgan's laws, that means it's an or of the individual negations. Then I just took this and wrote it in word form. All right. So this not for it is raining, put the not raining on there. That is an or. That's a disjunction symbol, so it's an or. And this not Q, because Q was I do not have an umbrella, that negation of that not changes it to I do have an umbrella. Okay. There are 3 logical variants of the conditional statement of P to Q. We have the converse that flips the order, that changes it from P to Q and changes it to Q to P. We have the inverse that takes the original and negates both. And we have the contrapositive, which flips the order and negates both. So you can see it changed Q and P and it negated both of them. The converse and the inverse, those two are logically equivalent statements. The original and the contrapositive are logically equivalent statements. Okay, so here's a statement. This thing is kind of messy. We're going to write the converse, the inverse, and the contrapositive for this. All right, the converse. The converse takes the original statement and just flips the order. It just makes the second thing first and the first thing second. All right, so it just flips the order, okay? I have this linked in D2L as a summary sheet as well, so you can always reference that. Okay, so the converse flips the order. So we've got this first thing and we've got this second thing. So you guys know how I feel about colors. So let's accent, this first and this second. First thing being what's to the left of the arrow and the second thing being what's to the right. Flips the order, just puts the blue stuff first. So Q and P goes first and not P goes second. That's it. Easy peasy. It just flips the order. All right, so the blue goes first and then the yellow. The inverse is going to negate both of those in the original order. Okay, so I'm going to leave this in the original order, and this is going to negate both. All right, so negates both. So then I'm going to take this first thing and I'm going to negate it. Then I'm going to negate the second thing. All right, let's throw some highlighter on here. So there's my original order, and look, this negates both of them in the original order they were in. Now, you could leave it like that, but Alex is going to want you to clean it up just a little bit. These two negations side by side like this are going to end up undoing each other. It's like the umbrella problem from the last one, right? I don't not have an umbrella. So that not is going to make that a positive. So that's just going to be plain old P, and then the conditional not Q and P. You don't have to feel obligated to use De Morgan's laws right there. So that's going to simplify. So you might find yourself where all you have to do is flip the order or negate both, and that's it, you're done. There may be some where you have to do a little simplifying first, like any of these like nots that show up. All right, the contrapositive is the worst one because it's a combination of the converse and the inverse. We're going to flip the order and negate both. So it flips the order. And negates both. That means the blue is going to come first and it's going to be negated. So I've got the negation of the blue coming first, then I got the negation of that one. All right, so negates both, boom, boom, flips the order. So you can see now that the blue is coming first and the yellow is second. Just like with the inverse, I'm going to simplify this. All right, so that's going to be, my final answer is going to be not Q and P implies plain old P. Okay, so remember, like I said, this this stuff right here is linked as a summary sheet in D2L for you. So kind of a quick reference guide if you should need it, so you don't have to come back to the notes. Okay, so that finishes section 3.3.